Alright, hi everyone. Let's continue with our data structures and algorithm series. In our previous video, we saw some common problem solving patterns like divide and conquer and frequency counters. In today's video, we will see another pattern that is multiple pointers. Let's see how it can help us in solving problems with better time and space complexity. To solve a problem with multiple pointers, first we need to do is create pointers that correspond to an index or position. And then we have to move these pointers from one position to another position to get the desired output. They can move in any direction. It can be either from end to beginning or beginning to end or maybe from beginning to middle. Let's try to understand this pattern with an example. I already have an example written here. As you can see, write a function called sum0 that accepts a sorted array and returns the first pair of integers where the sum is 0. Meaning we need to find out two integers from this sorted array that has the sum as 0. Let's take this array as an example that has integers from -3 to 4. So to solve this problem with multiple pointers, our first step is to define pointers. Now as we know, we need to find out two integers that has the sum of 0, which means out of these two integers, one integer will be negative and the other one will be positive. Since this array is a sorted array, we know the negative values will be on the left hand side and the positive value will be on the right hand side. So what we will do, we will define the pointers at both the ends of this array. Let's see it visually. As you can see on this screen, I have defined one pointer I at 0th index and the other pointer j at 6th index. The 0th index has the negative most value and the 6th index has the positive most value. Now if we do the sum of these two numbers, it does not give us 0, it gives us 1. As we know 1 is greater than 0, meaning the positive value is greater here. We need to reduce our positive value. So what we will do, we will move our j pointer to the next positive value, that is 2 here. Which means we are moving from 6th index to the 5th index here. Now if we try to add -3 and 2, it gives us -1, which is again not 0, and this time the value is smaller than 0, which means the negative value is greater here. Now we need to balance it out. We need to move our negative most value to the next negative value, which means I need to move the I pointer to the next index. And after moving the I index, we have the another value that is -2. We will keep the j as it is, we don't need to move it. And now if we try to add these two values, you can see it gives us the 0 value, which is our desired output. And that's how we found out our first pair that gives us the sum 0. As you can see, this pattern helped us in finding out our desired output in very less number of operations, right? If I show you how a naive person will try to solve this problem, it will be something like this. The naive person will try to iterate over the array and then he will try to compare each value one by one. As you can see in this example, we are having one parent loop and one nested loop, and we are trying to add both the numbers and trying to check whether their sum is 0 or not. In this case, the time complexity will be O of n square, which is not ideal. But if we try to solve this same problem with multiple pointers, it will give us the time complexity of O of n. Let's try to solve this problem with multiple pointers, this time on Code Sandbox. Before moving to the Code Sandbox, I would like to mention another good point of multiple pointers is this pattern helps us in solving problems with great space complexity. As you can see, we are not creating any new array or any new object, we are just moving inside the same array. which means the space complexity will be O of 1 here. Now let's jump to the code sandbox and see how we can solve it with multiple pointers in JavaScript. Alright, let's try to implement the multiple pointers solution here. So our first step will be to define the pointers, right? According to this problem, our first pointer will be at the 0th index, right? And the next pointer will be at the last index, that is nums.length -1. Alright, now we need to check the value of each pointer, whether they are able to give us the desired output or not, whether their sum is 0 or not. For that, I will use a while loop here, and the condition will be I should be smaller than j always. If I is greater than j, or even if it is equal to j, we can break this loop and conclude that there is no such pair that has sum of 0. So we need to check whether the sum of these pairs are equal to 0 or not. For that, we need to write a condition here. If nums I plus nums j equals to 0, then we will return the integers, that is nums I and nums j, right? Else if, let's say, their addition, let me just introduce a variable here called sum, so that we don't need to repeat the steps again and again. I will just replace it with sum, and here also, if sum is smaller than 0, in that case, if you remember, we need to move our pointer to the next value. If sum is smaller than 0, means our negative value is greater. Now we need to move our I pointer to the next value, because I here is pointing to the negative values. As I have already shown you the visuals of how this multiple pointer works. In that case, we need to do I plus plus so that I move to the next value. Else, if sum is greater than 0, then we need to move our j pointer, because j is pointing to the positive values. And if sum is greater than 0, means the positive value is greater here. Now we need to move to the next index so that we can balance it out. Now to move j to the next pointer, we need to do a decrement here, post decrement. Why? Let's see it in the visuals. If you see, we need to move our j pointer to the next value. We are moving towards the middle here, right? Because we cannot go beyond 4, right? So we need to move towards the middle, and we need to subtract something from our index value, and this will help us to do that. Alright, now let's try to open the console and see if this solution gives us the desired output or not. For that, let's open the preview tab. Let's open our console. As you can see, this one is giving me the output as -2 and 2, and this pair has the sum of 0, which means our multiple pointer solution is working as expected. To verify it again, we can take another example. For that, I will just comment out this one, and then let's try to remove this 2 with maybe 3. Oh, right, we need to change this one as well, 5, and what we can do is we can remove this one as well. Alright, now this example does not have any pair of integer that has sum of 0. In that case, our multiple pointer solution will return undefined. As you can see in the console, it is giving me undefined here. Alright, so that's all. That was about multiple pointers and how we can use it to solve our problems to get better time complexity and space complexity. Thanks for watching.